Hello everyone. Today I'm going to introduce you the BIM docking scheme and application. So first, let's look at what is the BIM. So the BIM is a building information modeling or the building information management. And it's based on the various relevant information data of construction projects to establish a 3D building model and simulate what's the building process through the digital information simulation and the real information. In construction projects, we usually abstract buildings, bridges, or the tunnel and other features into detailed BIM models, and the entire geographic environment around them is composed of 2D maps or GIS data in 3D scenes. And during the construction process, there will be many uncertain environmental factors that will affect the construction progress, such as weather, traffic, people, the density of the people, and these factors will also affect the operation and the maintenance of the entire project. So the combination of the BIM data and GIS data can be monitored in real time, and the external environment and the internal construction process of the project improves the construction efficiency and saves the construction cost. As a large amount of the BIM data accumulated during the design and construction of the BIM technology, and it can be used as an important data source for the 3D GIS application. And compared with the 3ds Max models data, and BIM model data is more refined and accurate, and has completed the semantic and attribute information, which can meet the needs of the refined management in the GIS applications. In addition, the topological structure of the BIM model data is more complete and more suitable for the spatial query and the spatial analysis. The BIM provides a 3D data support for the deeper application of 3D GIS. And the connection between BIM and GIS. Why we connect BIM and GIS? So for the BIM, the entire life cycle of the BIM from design and its construction to operation and maintenance is aimed at the refined BIM model, but it cannot be separated from the surrounding macro geographical elements and become a castle in the sky. So GIS has always been committed to the study of the macro geographic environment and providing a variety of the practice GIS query and analysis and spatial analysis, as well as the GIS location surveys and spatial analysis, provides a dedicated dynamic simulation function for BIM, and in the operation and the maintenance stage of the BIM, GIS can provide the decision support for it. So BIM needs GIS. And for the 3D GIS, BIM data is an important data source of the 3D GIS, which can make 3D GIS move from the macro to the land, and at the same time, it can realize a fine management. On the other hand, The integration with the BIM data enables 3D to move from the outdoor to the indoor, and realizing the integrated management of indoor and outdoor. So that's in our class. I'm going to introduce you the this part. There's 4 parts of the BIM. So the first is a connection between the BIM model and GIS platform. What is the requirements of the BIM and GIS? We have the rich BIM model and its attribute information. So we wanted to import the model and the attribute as a one time, and we wanted to import the BIM model refinedly, and it will be the optimization, and it will be more fast or more smooth in our browser, in our Windows. And if we wanted to do some application like the hierarchical management in the BIM software, and we could do this application. So there are many BIM software in the China and abroad, but the file formats are different. In order to break through the bottleneck of the BIM data access to the GIS platform, SuperMap uses export plugins and conversation tools to achieve a seamless cross-domain connection between the BIM and the GIS data interface, and converted application lays the foundation. There are 3 ways to import the BIM data. Directly import the BIM or use a plugin and the format conversation tool to import the BIM, and the export to the Interchange format and import it in the desktop. And let's look at these 3 functions, these 3 methods. So first, introduce use the export to the Interchange format and import it. So we could use the BIM software or the third-party plugins to export the BIM data to the data exchange formats supported by the SuperMap. And the exchange formats supported by SuperMap are the OSGB, OSG, S3M, or the OBG, IFC, 3DS, or something, or some format, and it could support directly import from the SKP DWG format. Okay, so for the export to the interchange format and import, it may lose some attributes, and we should set it a model position, include the longitude, latitude, and elevation in this Windows, and then that is our first interchange format. We aren't recommend this method, and let's look at the next method. It's a Revit plugin. It's a user plugin in the Revit software. So in the Revit software, we could in the plugin button in the plugin tab. There have the export plugin of the SuperMap, and click it. It will appear this window to set some parameters and import this model to our at desktop. So we just say we don't recommend you to use this interchange format. For the advantage of the user plugin, it's could one click to import the BIM vertex information and attribute information to ensure the integrity of the BIM information, and it support export by the group and provides a fast BIM group management. And it could also support the efficiency rendering of the large-scale data, and it could support the export of the topologically closed BIM and the three-dimensional volume data model, which can calculate its volume and surface area and any cross sections, and can perform the spatial relationship judgment and spatial calculation and spatial analysis, and support the 3D printing. So that has many advantages of the BIM export plugin. Okay, so let's use this video to look at how to use the plugin and export the BIM data from the Revit and import this BIM data to the desktop. Okay, let's look at it. First, we could click this 3D views, and then click add-ins and select the SuperMap export. It will to appear this window, and let's look at this intersection point. The intersection point is the coordinates of the control point, and where the model is placed in the three-dimensional space when the model is export according to the difference of the projection. It is divided into a spherical insertion point and a plane insertion point. So when we export this model, the insertion point and the project based point are the point with the same name, and the vertical of the model are exported relative to this position. So when the spherical insertion point is exported, and the coordinates of the insertion point are the latitude and longitude coordinate system, and use the planar coordinates, it will import by the x, y based on the planar coordinate system, and the base point must be 0, and the plane insertion point does not need to consider the coordinates of the project base point. So the xy must be 0, and if the model position is not considered during the modeling, and the offset value can be set on the project base point to solve this model position problem. So it's spherical, so its insert position is its ordinary points. And we could select the data source to store our BIM data, and we could set its some another parameters like the color tab and the to select the export normal or some another parameters. And then and then we click OK to export the BIM data, and wait a minute. It will promote us exported successfully. And then let's open the desktop and open the data source that we have set. Okay, and then add this to our desktop. Okay, we could click this invisible and click zoom to the layer and to see that is the BIM data. And we could also click the part of the BIM data, and it will we could see its attribute table of the BIM data. So we use a plugin to import our data. It will also import the attribute field of the BIM data. Okay, that's the Revit export plugin method to import the BIM data. And the Revit export plugin selects the corresponding plugin version according to the Autodesk Revit software version, and installs it in the Autodesk Revit. It supports exporting the BIM model to the UDB format, and the SuperMap platform directly reads the data. And then let's look at the Bentley plugin export. It is the same as Revit. We should to set its insert point and its project and its data source of the BIM model. And so it's also applied in the DNG, and the DNG export plugin could also select the corresponding plugin version according to the MicroStation platform version, and it exports so many data formats. And then it's a Catia plugin. The Catia export plugin selects the corresponding plugin version according to the Catia platform version and installs it on the Catia platform. It supports exporting the BIM model to the UDB format, and the SuperMap platform directly reads the data. The following figure shows the display effect of the BIM model data on the Catia platform and the SuperMap platform. It's also to set its insert points, and it could also set its output path and output tab in there, and set its insert points in the model location, include its longitude, latitude, and elevation. And it also set its another planar location platform. Okay, that is a Catia plugin. It's the same as another plugin, and the Civil 3D plugin is also same to this plugin. And for the NFC, the NFC conversion tool supports the exporting the BIM model in the NFC format to the UDB format. and the SuperMap platform directly with the data. And in this following figure shows the display effect of the BIM model data in the IFC format and the SuperMap platform. And in this video, we could select the IFC and just to export to the UDB, and open this UDB to look at how to use this plugin to export the BIM model. Okay, and for the link that is Baidu network disk link. So that's more, maybe that is forward to some users in the China. So maybe I don't know for the for region people, for the abroad people, what link is this, and I will check it. And then let me introduce you our third format, our third method to import the BIM data, that is a directly import. Let's look at this video to look at how to directly import. Okay, maybe that is a little fast. Okay, click. Let's look at this video. First, right-click our data source, and it will have the right-click it, and it will have the open the BIM data, and we could just to open the RVT data, and it could just open the import the RVT data of the Revit, and we could select the data source and modify its point, its latitude and altitude, and we could also use this to directly import to our plugin. So we just recommend you to use a plugin, and that is a way you could also to import it. Okay, and that is a 3D Max. It is in the, we could see, we can right click our data source, and there have the import the BIM data, and click the 3D XML, and open the 3ds XML data, and modify its insert point, and modify its projection, and import it to our desktop. And that's another way to import the 3ds Max model. Just to right click the data source, and there have the import the BIM data. Okay, that is the connection between the BIM model data and the GIS platform. And then let's look at the coordinate system of a BIM model data. Okay, so first, when we set the coordinates of the BIM model, we should set the insert points of the coordinate system. And I have introduced you that a point and the project base point, and that is we should use a measuring point and the world coordinate original point as the insert point, and the project base point and the insertion point and the measurement point is the original of the reference coordinate system for the actual measurement and the position. of the project in the world coordinate system, which can generally be understood as the position of the project in the city coordinate system. And the projection base point is the relative reference coordinates and origin of the project mirrored and positioned in the user coordinate system. And then we should set up its projection file to set its origin of the geographic or projected coordinate system. And if it's a local coordinate system, first we should set it to the value of the local coordinate system, or use the local coordinate system projection file and export and import the data, and then convert it to the WGS84 according to the offset of the local coordinate system, or the 4 or 7 parameters conversion method to convert it. Okay, and if we set its coordinate system, but its coordinates value is not right, we could use registration to register our BIM model. That is in the start menu, and there have the registration, and click the new 3D registration to do it. And let's look at the operation. We have this BIM model, and let's zoom it to the layer. That is the oblique photography model, and there have the 3 in the tab of the start. There have the registration, and click the new 3D registration and select the data site. And that is a BIM model. That is our oblique photography data. And select its point, and select a point in the reference layer. That is the oblique photography layer, and select the Y and the X. So when we click the point in the windows, it will appear its original X and Y coordinate system in there. And then we should click the true XY coordinates in there, and then to generate its arrow and to do the registration, and click OK to registration. And then let's zoom in it and set its altitude and longitude, and zooming it, so it's a successfully registration in this correct area. So that video is in Chinese, and I have just to introduce you how to do it. So if you have some question, you can contact us with this operation. Okay, that's successfully to do the registration. Okay, and then if your projection is not correct, you should to do the conversion of your projection. That is in the start menu and the projection conversion, and you could click the data site projection conversion, and you could set it in there, set its 3 parameters or 4 parameters to conversion your coordinate system as a latitude and longitude. So that's how to do the conversion, the projection conversion. And then let's look at the BIM model data editing and the attribute update. And the SuperMap 3D platform can not only edit the geometric information and attribute information of the BIM object, but also edit the certain object of the BIM object. So we could use the desktop to modify its information. Just right click it and modify its properties. And it could also edit the model objects, the more certain model objects you for example, you could adjust to modify some walls, the attribute objected, and it also support export it as OSGB or OBJ file. And in addition, in order to facilitate users to edit the position of the BIM model more conveniently, and the SuperMap products provides a batch editing function of the model data site, which can perform the operations such as translation and rotation on the entire data set layer. And we could set it in the tab of the 3D designer, and that is the triangulation operation button. You could set its model edit to rotation and translation the BIM model. And then you could also the model edit the BIM model attribute information by update its column and obtain the line or supply the data site or another operation. Okay, and then let's look at in the SuperMap the fusion of the BIM data and terrain data is supported. It's a mosaic, and when mosaic the BIM data with a 3D terrain data, and the clips, the digging, and the mosaic functions of the TIM terrain data and oblique photography models can easily realize the effect of the BIM embedding terrain and embedding oblique photography models and another functions. So let's look at this video. A mosaic of the BIM data and terrain data. The BIM provides the macro data information, and the terrain data provides the location information of the BIM model in the macro environment and the surrounding environment. So through the integration of the multi-source information, it provides the users with a more realistic and accurate visualization experience. And the 3D spatial analysis data supported. As shown in this video, the BIM model of the hydropower station is integrated with the 3D terrain data to provide the hydropower enterprises with construction, operation, and the data support in the management phases. So it's use the terrain data and BIM data to realize it's a mosaic. And for the BIM data and the oblique photography model, you usually use a different coordinate system. So before fusion, before mosaic and matching coordinate system conversion is performed first. So SuperMap platform not only supports the coordinate conversion function of the model data, but also in registration function of the model data, which can facilitate the automatic conversion of the BIM model in the engineering coordinate system to the specific coordinate system. So let's look at this video. The mosaic photographic, the oblique photographic model in its area where the BIM model is located needs to be flattened, and the slope protection parameters can also be set to achieve a smooth transition and the data connection. So realize the fact as a data connection and the realized effect combination of the oblique photography and BIM data. And on the one hand, oblique photograph data can be used to build a surface model of real-world buildings in batches, and which can be used as a base map. So on the other hand, the internal structure of the building can be generated through the BIM data to achieve the more precision data analysis and the modeling. So the solution can be applied to indoor navigation to provide the visual guarantee. So that is to matching the BIM and BIM and oblique photograph model. Okay, so that is how to edit and attribute attributes update the field of the BIM model. And then let's look at the BIM model performance optimization strategy. The BIM model performance optimization strategy includes these parts, and let me introduce you successfully. Okay, and so taking the that is the optimization strategy of the BIM model. So let's taking architecture data of the building as an example first. There are more than 6,600 graphic elements categories open in the Revit softwares, and each graphic element contains a lot of attribute information. So we adopt performance optimization technology to meet the performance needs of the large amount of data. And there have these three technologies to mention here. And first is instanted. The instantation technology is suitable for the situation where there are many repeated models, and the same geometric model can be drawn only once, which reduces the pressure on the hardware device, such as graphic cards. And as shown in this figure below, there are a large number of the same door objects in the house. So using the instanted functions and rendering the technology, only one object is saved and drawn, so which reduces the pressure on the graphic card and the memory, and improves the performance of the 3D scenes. Okay, that's instanted. And for the LOD technology is abbreviation of the levels of the detail, which means multiple levels of the detail. So LOD technology refers to determining the resource allocation of the object rendering according to the position and importance of the node of the object model in the display environment, and reducing the number of the faces, the surface, and the details of the non-important objects, so as to obtain the efficiency rendering operation. And the multi-level of detail, when the 3D scene is zoomed in and the model is very detailed. So when browsing the entire scene, and the model only needs to be displayed in a rawer way, which optimizes the resource usage to the greatest extent and improves the performance of the entire 3D scene. Okay, and the third is triangulation simplified, and let's look at it in details. So the triangulation simplified, the BIM is a high density model that accurately and comprehensively displays and the internal and the external models of the building. So the amount of the data causes the 3D scene performance of the BIM model to be improved. And some BIM models have a lot of the redundant triangular surface, such as certain branch piers or these door handlers, and locked cylinders, and so on. So through the triangulation simplification and the effect of the batch simplification of the similar BIM model is realized, and the memory occupation is reduced, and the performance needs of the large amounts of the data. And that is a triangular simplified. And then let me introduce you the remove duplicate point. So for the BIM model, the purpose of the simplification is achieved by deleting the useless sub-objects, and the performance of the 3D scene of the model is improved. For example, the door objects as shown in the figure below, and that is a bridge. And the single bridge objects, the number of the vehicle of the so many, the 743,000. Yes, and when we do the remove the duplicate points, and that is 2284, of which bridge and its a cylinder occupies 80% to the 90% of the data volume. And the data volume of this bridge will be even greater, and these components have no practical application value for the GIS. So delete or simply these skeletons to achieve the purpose of the reducing the weight of the model. Okay, so for the triangular operation, let me tell you where it is. So I have opened the BIM data that I sent to you, and for this data, And in the 3D data tab, there has the model data. We could in there we could remove the duplicate the vertex or delete the duplicate sub-objects. In there, we could do some operations in there. And for this button, we could import the Revit or 3D XML data. And in the tab of the 3D designer, we could use a triangulation operation to do some extraction shell or triangulation or operation of the sub-object. So because our BIM data are a little small, so if you have some data, you could use this function to look at how to do it. So that is in there. In the modeling 3D designer modeling group and in the 3D data model group. Okay, let's come back to the PowerPoint. That is how to optimization the BIM data. And there have another operation to generate the S3M layer cache. This I have introduced you in the second course. And for the publishing and sharing of the multi-source 3D spatial data service, and SuperMap is the first in the China to propose an open 3D spatial data tile format, the S3M spatial 3D model, which solves the problem of the efficient transmission of the massive and multi-source 3D spatial data in the network and offline environments. And the problems of the exchange and visualization on the multiple terminals have greatly promoted the construction of safe and controllable open and shared 3D data assets in my country. So, S3M is a data format suitable for the transmission of the massive 3D model data. It meets the needs of the users for 3D data transmission and analysis on the different terminals, like the mobile, browser, desktop, and through an efficient, easy to extend, and collaborative data specification. By generating the BIM data into the S3M cache, and the data transmission speed and the terminal visualization effect are improved. So we could use this generate S3M function to to improve its efficiency of the data. So we could right-click our data site and generate a cache, or click the 3D data menu to batch generate a model cache, and that will generate one file of the S3M. And then, or we could right-click the target scene and generate the scene cache. Okay, and then let's look at our next part, that is typical application direction of the BIM model. So first is that get a projected stretched body, which is a white model. When we get this BIM model, and we could do the projection polygon to generate this this vector data and the linear stretch it to the white model and use it in the application. Or we could to just projection stretch it and add as a white model and to apply it in the application. And then it could also apply in the spatial query. And the 3D spatial relationship judgment merely refers to the query and the retrieval of the 3D body models by judging the mutual relationship between the 3D body models, including the inclusion and intersection, separation, or something, and so on. And in this figure, and the row and the buffer object is obtained by performing a 3D buffer analysis on this building. And using the 3D relation query, you can obtain the non-compliant buildings within a certain range of this building. And then that is check the some buildings near your buildings, or check the buffer, the range of these buildings. So in this design stage, the problems are discovered and corrected in time to avoid the losses. And that is a wear withdrawal detection. And that is a BIM helps engineering construction. We could use the query or hierarchical display to analyze the BIM model, and to dynamic simulation of the construction process, or assistant in the monitoring construction process. For example, we could use a conversion of the 3D city model into a house plan outline map, improves the data utilization rate, and saves the results and reduce the acquisition cost of the 2D data to a certain extent. And in the real space, there will be some contradictions from space. For example, some buildings affect the skyline of the city, or some buildings affect the visible range of another building. At this time, it is necessary to construct a digital rule or library through the digital translation in the accordance with the control regulations of urban planning. With such a rule base, it is possible to resolve or avoid spatial conflicts in the process of urban construction and provide the technical support for the intelligent management and control of urban planning and urban design. So first is a query. We could click one component and to query its ID or its materials, or select it to invisible or visible. Or we could look at its inner model to query one wall or something else. And this is construction simulate. We could simulate its process of its construction, and that is process to construction the whole building. That's all of both of these are the application of the BIM data. And then that is smart supervision project platform, the Beijing Subcenter. That is a typical large-scale construction management project, and this is jointly built by the Beijing one company in Beijing, and Beijing and the SuperMap in this project breaks through technical problems such as accurate matching of the BIM and GIS data as a centimeter level and real-time drawing millions of the BIM models. So the platform uses multiple key technologies such as BIM, GIS, Internet of the Things, or big data, intelligence, mobile communication, or something to integrate the project management on the video management, or the Internet of Things platform, or the big data platform, or the labor management and other business system to integrate the building BIM models data and the structured data. And it's realized the refined management of the construction projects and the comprehensive monitoring and the intelligent management of the implementation of the one-site environment, safety, quality, and the process. Okay, and then that is BIM and the GIS and VR. So with the help of the emerging technology in the field of the IT hardware, SuperMap has also made the major breakthroughs in the enhancing display effect and human-computer interaction with the help of VR devices. And SuperMap products support the VR prehensions such as the HTC Vive or something, and it's making the 3D GIS application have a richer sense of the vision and or experience on the human-computer interaction. As a good carrier for 3D GIS to realize the real perception of the virtual space, it supports the handle picking and the query functions and provides a keyboard-driven automatic walking and automatic running browsing moves with accurate indoor collision detection, and combined with indoor and outdoor multi-source data such as BIM lets you feel a more realistic 3D immersive experience. And this is BIM and AR. The AR is augmented reality through the IT technology applies the virtual information to the real world, and the real environment and the virtual objects are the superimposed on the same screen or space in the real time, so that the people have the deeper understanding of the objective world and awareness. So SuperMap provides a support for AR functions, that is support the projecting models in the virtual world into the real world. As shown in the video below, AR technology is used to project the BIM model into the real world to achieve the integration of the real environment and the virtual environment. And this kind of the technology can be used in engineering, construction, water conservancy, and hydropower survey and design, or the navigation and other industries to project a 3D model into the real world and realize a 3D collaborative design and navigation data based on the virtual model. And Through the AR system, it is easy, fast, and accurate to obtain the geography, weather, climate, and other related data of the prescribed position, and so on. So that is the BIM and the AR. Okay, so today's class is over, and thank you so much.